Welcome back to my channel. Today we are continuing with the chapter continuity. In this video I will discuss the questions of the exercise 5C. In these questions we have to discuss the continuous function in domain. Now let us start. Question is, examine the following function for the continuity. Given function f of x will be equals to mod of x minus 5. Firstly, we have to given that function is f of x will be equals to mod of x minus 5 and function f is defined for all the real numbers. Function is defined for all the real numbers. Then let c be any real number. Then f of c will become, that means x will be equals to c. Function at x will be equals to c will be equals to mod of c minus 5. Now we have to take the limit x approaches to c. F of x will be equals to limit x approaches to c. Mod of x minus 5 will be equals to c minus 5 when we put the limit x approaches to c. Then limit x approaches to c, f of x will be equals to f of c by using first. So f of x will be equals to f of c. So therefore the function f is continuous at x will be equals to c, but c is any real number. So therefore f is continuous at every real number. So hence proved. Now second question is discuss the continuity of the sine function. That means f of x will be equals to sine x, where domain will be equals to all the real numbers. So now let a be a real number which belongs to domain of the function. Now we have to take the limit x approaches to a. F of x will be equals to limit x approaches to a sine x. Now here we have to put x will be equals to a plus h, so that h approaches to 0 as x approaches to a. Now we have to put the value of x will be equals to a plus h, and we have to take the limit h approaches to 0. That means limit h approaches to 0 sine a plus h. It will become sine a plus b will be equals to sine a cos b plus cos a sine b, and limit remains as it is, limit h approaches to 0. Now we take the constant function outside, that means sine a limit h approaches to 0 cos h plus cos a limit h approaches to 0 sine h. Now we will have to put the limit h approaches to 0, then it will become sine a cos 0 plus cos a sine 0. And we know that cos 0 is 1, so it will become sine a into 1 plus cos a into sine 0 is 0. So we get sine a, so which will be equals to f of a. So therefore the limit x approaches to a f of x will be equals to f of a, that means sine a. So therefore the function f is continuous at x will be equals to a. But a is any real number? Which belongs to domain of the function. So therefore the f is continuous function. That means sine x is continuous at every point of its domain. Sine x is continuous at every point of its domain. Next question is, determine if f is defined by the function f of x will be equals to x square sine 1 by x if x is not equals to 0 and f of x is 0 when x will be equals to 0. Determine that the given function is a continuous function. Now let us start. We have to given that this is the function f of x will be equals to x square into sine 1 by x when x will be equal not equals to 0 and 0 when x will be equals to 0. And we know that for the domain of the function will be equals to the real numbers. Now we have to let a be any real number. If a be any real number, then in the function we given that the condition for x is not equals to 0 and x will be equals to 0. If a be a real number, then we have there be two cases. Case 1 is a is not equals to 0 and in case 2 is a will be equals to 0. If a is not equals to 0, then we have to take the limit x approaches to 0 f of x, which will become limit x approaches to a x square sine 1 by x. This is the given function. Now here we have to put the limit, then we get a square sine 1 by a. So therefore the limit at x approaches to a, here we will put the limit, then it will become f of a, which will be equals to a square sine 1 by a. If this will equal, then therefore the limit x approaches to a, f of x will be equals to f of a. So therefore the function f is continuous at x will be equals to a and a will not be equals to 0. Now in the second case is when a will be equals to 0. If a will be equals to 0, then we have to take the left and right handed limit. So for this, firstly we will take the left hand limit, that means limit x approaches to 0 negative f of x, which will become limit x approaches to 0 negative x square sine 1 by x. Here we have to put x will be equals to 1 minus 0 minus h, where h is greater than 0, so that h approaches to 0 as x approaches to 0 negative. This is the left handed limit. Now we have to put the value of x 0 minus h in this, then it will become limit h approaches to 0 0 minus h whole square sine 1 upon 0 minus h. Then it will become limit h approaches to 0 minus of h square sine 1 by h, which will become, by putting the limit h approaches to 0, it will become 0. Here will be the term h square and sine 1 by h. Here we also use that limit h approaches to 0 h square will become 0 by putting the limit, and sine 1 by h is a bounded. If it is a bounded, this is bounded because sine mod of sine 1 by h is always less than 1. So this is the bounded function. If this is the bounded function and this will be equals to 0, so therefore limit h approaches to 0, minus of h square sine 1 by h will be equals to 0, because we know that limit x approaches to a, f of x into g of x will be equals to 0 if limit x approaches to 0, f of x will be equals to 0 and g of x is bounded. If limit x approaches to 0, f of x is 0 and g of x is bounded, so here will be the same condition that limit h approaches to 0 is 0 and given function is bounded. So therefore this term will become 0. Now similarly we have to solve for the right handed limit, that means limit x approaches to 0 positive f of x. It will become limit x approaches to 0 positive x square sine 1 by h. Now we have to put the value of x. We have to put x will be equals to, for the right handed limit we have to put x will be equals to 0 plus h, where h is greater than 0, so that h approaches to 0 as x approaches to 0 positive. So it will become limit h approaches to 0, 0 plus h whole square sine 1 upon 0 plus h. That means limit h approaches to 0 and this will become h square into sine 1 by h. As discussed previous, if the limit of x approaches to a, f of x will be equals to 0 and g of x is bounded, then the limit x approaches to a, f of x into g of x will become 0. As limit x approaches to 0, f of x is 0, then g of x is bounded, then this will become 0. Here we have the term limit h approaches to 0 h square. It will become 0 by putting the limit, and this is the bounded function, so therefore the value of this will become 0. So therefore the function at x will be equals to 0 will be equals to 0, and therefore the limit x approaches to 0 negative, f of x will be equals to limit x approaches to 0 positive, f of x will be equals to f of 0. So therefore function f is continuous at x will be equals to a, which will be equals to 0. If you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.